warahmatullahi wabarakatuh. My name is Nur Shamina binti Suhaimi as the leader group of Group 4. Here we are to present the project assignment video presentation about the design of IPv4 and IPv6 network addressing for small and home network. Alright, so let's get started. Before we move to further explanation, I want to introduce the group members that will present in this video, which is Shaza Afika, Wan Amira Zafira, Umaira Shafika, and last but not least is myself, Nur Shahmina. The agenda of these video presentations consists of introductions of IPv4, introductions of IPv6, introductions of VLSM, the VLSM addressing, summaries, and conclusions.
Assalamualaikum, my name is Shaza Afika. I will explain about the introduction of IPv4. IPv4 stands for Internet Protocol version 4. It is widely used protocol in the data communication or different types of network. It provides logical connection between network devices by providing identification of each devices. IPv4 consists of 4 numbers which separated by the dots. Each number can range from 0 to 255, but computer do not understand decimal number, so it will convert to binary form which it can be understood from computer. Each number of A is represented by a group of 8 digits of binary number, so IPv4 is a 32-bit address. 2 power of 32 is approximately 4 billion devices that can be connected to internet with IPv4.
Bismillahirrahmanirrahim. My name is Umaira Shafika. I will talk about the introduction of IPv6. So basically, IPv6 is Internet Protocol IP address standard intended to supplement and eventually replace IPv4 binary digits, which is the protocol many internet services still use today. For the key benefits for IPv6 is it is better multi-case routing and simpler header format. As you can see from here, IPv6 is 128-bit IP address, which is 2 power of 128. So from here you can see that the number of IPv6 addresses is 1028 times larger than the number of IPv4 addresses.
Let's go to the introductions of VLSM. What is VLSM? VLSM stands for Variable Length Subnet Mask, which provide a lot more flexibilities over addressing scheme. It also allows customizing the number of subnets and addresses based on the network's particular requirements. The bottom of slide shows the benefits of VLSM, which is allow efficient use of address spaces, allow the use of multiple subnet mask lengths, allow the row summations, and other benefits of using VLSM. This is the network topology diagram that given in the questions. We are required to choose any classes and need to determine the IP address for each network by using the VLSM method. We provide the IP address of 192.168.223.0 and the class is class C. Because of the class that we choose is class C, so the default subnet mask will be 255.255.255.0. We also need to provide the host for each network, so we decided to set a home entertainment network for 125 hosts, 30 hosts for the Wi-Fi network, 60 hosts for home office network, and the last one is the home office server network with 13 hosts. To determine the IP address for each network, we need to consider the larger to smallest hosts. The first host, which is the largest, is 125 hosts at the home entertainment network. Before find the LAN address for host, we need to know the network bit and the host bit. So we can find the network bit by using 2 power of n, which is n equal to the network bit. In our cases, I use 2 power of 7, which is equal to 128. And how to check whether this network bit is usable or not? We can minus it by 2 and get the value of 126, which means the value is greater than number of hosts, so it can be used. To find the host bit, I subtract 8 bit, which is the total bit for class C, and with the network bit, which is 7 bit, and get the value of host bit, which is 1 bit. And the subnet mask for host 135 is 24 bit plus number of host bit, which is 1, and get the value of 25 bit. So the subnet mask is 25 bit. If the subnet mask converted into decimal form, we will get the value of 255.255.255.128, and the subnet mask in binary will be like shown in the bottom of the slide. So in conclusion, the LAN address for host 125 is 192.168.223.0/25. The last digit of the IP address can be found by using box method of host portions at the next slides. For the box method, I sorted by through a whole square, which is the host portions, which consists of 256 addresses. Then I split the box into half to get the host portions of 128 hosts. So the usable IP address is in the range of 1 until 126. The number of upper left corner of the yellow box is actually the value of network address for 135 hosts, and the bottom right of the yellow box is the value of broadcast address. And the IPv6 for this network is stated as 2002:C08/DF00:0:0:0:0:0:0.
Okay, next I will explain about the blue box. The blue box have 60 hosts. So from here, you have to find the number larger than 60. So which is I choose 2 power of 6, which is equal to 64. So from here, you can check by 64 minus with 2. So from here, you will get 62 bit, which is can be used because it is larger for to number of the hosts. Okay, from here, the network bit is 6 bit because 2 power of 6, the number of 6 is the network bit. So host bit is 2. So for the subnet mask, you have to add the number of 24 bit with the host bit, which is 2 bit. So it is equal to 26 bit. So for the subnet mask in decimal is 255.255.255.192. So the subnet mask in the binary is like in the slide. Thank you. So from this slide, you can see the IPv6 address, which is 202.C08.DF80:0:0:0:0:0 and :0. So from for this slide, you can see the network diagram, which is the left side. We can divide the two, so we can get 128 and 128. So for this one, we use the 64 bit. So we have to divide the white side with 2. So we can get 64 bit. So that's the answer.
Note that the green one is the third largest host, which is 30 hosts. Then we need to find the network bit and also the host bit for the host. That is why we need to use 2 power of 5, which is equal to 32. Then we get that network bit is 5 and host bit is 3. To check whether 2 power of 5 is the right value or not, we can minus 2. 32 and minus 2 equal to 30. It means that we can use it because it is bigger than the number of the hosts. Why we get subnet mask 27? Because the default host bit is equal to 24, and then we need to add with the host bit, which is 24 plus 3 equal to 27. From this step, we get that IPv4 address is 192.168.223.192/27. The subnet mask for decimal is 255.255.255.224. Meanwhile, for the subnet mask for binary is sequence of 1 dot sequence of 1 dot sequence of 1 dot 111 00000. Okay, sequence of 1 means that it have 8-bit digit binary of 1. Next, we need to know IPv6. We can get directly from the IPv4. The IPv6 address for 30 hosts are 2022-6088-DF00000000. For the box method, we used 32. So from the remaining space, there was 64, right? Then we divided by 2. Then we get the value that we want. 192 until 2 to 3, we get 32 space.
Hi, my name is Wan Amira Zafira, and today I would like to explain my part what will happen if the host that being assigned is 13. First thing that we need to do is we need to 2 power of something that is close and bigger from the number of 13. So I choose 2 power of 4, which is equal to 16. Why I choose 2 power of 4? Because if 2 power of 4 is equal to 16, the 16 minus with 2 equals to 14, which means that 14 is larger and closer to the number of 13, so it can be used for this host. Next, the network bit is equal to 4 bit and the host bit also 4 bit. So the line address for this part is 192.168.223.224/28. Okay, why /28? Because of the subnet mask is 24 bit plus 4 bit, which is the host bit, is equal to 28 bit. So the subnet mask for this part in decimal is 255.255.255.240. So if we change it to the binary, you can see as in the slide. Now for the box method. So let's take a look first on the left box. So as you can see there, there's actually a white part which not has been occupied. But actually the white part is equal to 2, but we only need to use 16. So what we can do is we cut half of the box, which is 32 divided with 2 is equal to part. So as you can see on the right side, on the box of the right side, which is the pink part, the 16 is already been occupied, half of the white part.
And the last host is 2 hosts, which is at the connection between 2 routers. Same as before, to find the WAN address for host 2, we need to know the network bit and the host bit. The network bit that I get is 2, which is from 2 power of 2. To check whether the number of network is correct or not, we can minus the answer of 2 power of 2, which is 4, with 2 and get the value of 2 bit. Even though the value is equal to the host, it still can be used as long as it is not smaller than the host. The host bit is 6 because 8 minus 2 is equals to 6 bit. The subnet mask for host 2 is 24 bits plus number of host bit, which is 6 bit, and get the value of 30 bits. So the value of subnet mask is 30 bits. If the subnet mask converted into decimal form, it will get the value of 255.255.255.252. And the subnet mask, if it converted into binary form, it will be like shown in the bottom of the slides. And the WAN address for host 2 is 192.168.223.240/30, and the last digit of the IP address can be found by using the box method of host portions at the next slides. For the box method, I started with the remaining host portion, which consists of 16 hosts, and start with network address of 240. Then I split the box into quarters to get the host portion of 4 hosts in a single box. So the usable IP address for this network is the range of 1 until 126 for home entertainment network, 129 until 190 for Wi-Fi network, 193 until 222 for home office network, 223 to 238 for home office server network, and the last one is 239 until 242 IP address for WAN address between routers. And the IPv6 for this network is stated as 2002/C088/0/0/0/0/0/0/0/0/0, and that's all.
Last but not least, conclusion. IPv6 is the next generation Internet Protocol address standard intended to supplement and eventually replace IPv4, the protocol many Internet services still use today. IPv4 stands for Internet Protocol version 4. It is underlying technology that makes it possible for us to connect our devices to the web. The creation of IPv6 and its slow replacement of IPv4 has been a huge and critical innovation for the future of internet communications. The primary function of IPv6 is to allow for more unique TCP or IP address identifier to be created now that we have run out of 4.3 billions created with IPv4. This is one of the main reasons why IPv6 is such an important innovation for the Internet of Things. That's all from us. Thank you.